I'll just bring you guys in another video, I suppose another update, I suppose. Nothing too major, well I've already done a little bit of an update, but just in the mood for doing a video. Sunday today and working, doing a job on my manual mill, a job I need to get ready for tomorrow. Hoping to do some more work on the Mazak mission tomorrow if things go to plan, but you know how the word plan goes. You plan something, it very rarely happens, but hoping for the best. Just trying to get one full day to work on it. Just go for a little bit of another walkthrough, I suppose, without dragging it off for too long. And just a bit of a show around. We'll go around and have a bit of a look in the electrical cabinet and just show you where I'm up to as far as that goes. I've got the door mounted on now. As you can probably see, I've got no window in there at the moment. It was funny when I went to buy this machine, the door didn't actually, well, it opened, but it took a fair bit of effort because, as you can probably see, there's a bit of a sliding guide along the bottom there, where the bottom rollers, the bottom of the door runs on, and they had the panel removed from the inside of the door. I don't know why they had it off, but anyway, the chips and crap got inside and eventually jammed up one of the wheels, and they were just dragging the door open and closed without even, it didn't even really want to open, and it basically wore the round wheel flat. So as I say, I have no idea what. It was just easy to take off and repair it, but I suppose being an older machine, they didn't really care about that. I'm just going to have that mode if they're going to get rid of it soon, I suppose. A bit like an old car, I suppose, isn't it? You're going to get rid of the old car soon, so you don't really care about it, fixing anything else on it. But I've got that running nice, just give it a little touch and, sliding around. Need to put some rubber stops on up the top track. It's all lined up nice. So make sure we've got it all sitting good. All my little gaps set everywhere, so to make everything professional, I suppose, looking as much as the rest of the machine. I haven't got a handle on it yet. It did have a recessed handle in here that I chose to fill in, because normally when you're using, especially a CNC machine, you've got coolant and chips on your hand, and it had, as I say, a recessed handle in there, and all that eventually just builds up with crap. The other handle was like full of bits of coolant and chips, and it was rusted over because of being an older machine, of course. But I didn't bother putting the handle back on. It was on it. I could have cleaned up and put it back on, but the design, as I say, it's as a recess. So to actually get to be able to clean the handle, after you take it actually off the door to be able to clean it. So I'll be setting up something different, like an external handle there over the top, maybe a stainless steel rail, like a grab rail type of handle. I'll work that one out. But it just glides nice now. But just take you around to the electrical cabinet, just show you a bit of a look around there. Some of you might have already seen in here. It's probably not a lot changed actually as far as the main part of it goes. It's just what I'm doing at the moment. As I say, I've got time, is just pulling cables in at the moment and connecting up where they need to go. That's that heatsink I was talking about in the previous video, so that's the inside of it there. Cooling fans are on the opposite side there. So it brings the, this is obviously the inside of the cabinet, so it brings the cool air in through the bottom. Well, sorry, it brings the hot air in through the top. I'll get it around the right way. So opposite to the other side. Hot air comes in here, obviously hot air rises, comes in through the grill here, hits the heat exchanger and pulls the cool air out the bottom. That's the theory. And then you've got the fans on the other side, obviously being a heat sink, it transfers the heat to the other side, and that ducts the heat out to the outside. So you've actually got a sealed electrical cabinet then that's dust free. They don't like any dust inside the components. They really struggle in a dirty environment. CNC machines, always got to make sure you keep them. The electrical components pretty much spotless, I suppose you could say. I spent a bit of time making sure I went through and cleaned everything. Was more so the things that went to the outside. The spindle drive unit here, it has a heatsink on the back of it, similar to the one that's on the door, but a lot smaller, of course. And that was just full of crap because it just sucks all the air in from outside. It has two fans at the top, which I opted to change, as well as the ones I've talked about in the last video. The two on the door was just full of rubbish, just all the crap that's accumulated in the air. It just sucks everything out of the air. You don't realise until you look at the cooling fan how much rubbish is actually floating around in the air. And as with old machines, it does get a bit clogged up with rubbish. Just going to go for a little bit of how can I sort of put it into words? As you can see, I'm not that prepared to do this video, but I'm in the mood for it. but probably just go through a bit of an awakening, I suppose you could say. It's easy to be standing at the front of the machine, flick on the switch and press the button. I suppose that's all you really want to know about a CNC machine, I suppose, from the operator's side. You don't really want to care about what's going on at the back here, but it just sort of blows my mind a little bit, some of the things that it takes to actually run a machine like this. You don't really think about it too much, I suppose. When you're just thinking just what it is, and the machine's running, that's all you care about. But each one of these panels here, I suppose you could say, each one of those runs each servo motor. So you've got the X-axis drive here and the Z-axis drive here. So one of those just drives one of these. So of course it's got to run it at a certain rate and feed rate and so on. But I mean, all it's doing is just pulling the compound or the slide or whatever's mounted on top of it backwards and forwards. That's all it does. It's just crazy how much effort there is just to be able to make this move at the right rate at the right time. You sort of take it for granted, as I say. So as best as I can, I've gone through and labelled everything, more so just for reference in future, in case I'm having drums I need to diagnose things and trying to work out which one's which, when I'm trying to work out which side is Z and which side's X. So I start trying to diagnose things as best as I could. If something's failing, you try to save yourself some money and trying to sort things out yourself before you call the tech in. Sometimes it's a simple thing and sometimes it's something you can't do, but just going through and just labelling things off. You can probably see there, these are the circuit breakers so I've still got to bring the cables in. Obviously got it connected on this side. We've got some power. I've got to bring cables in from the transformer, which I'll take you over in a second and show you. So you've got a different circuit breaker here for you. So this is the X and Z one, you can probably see on top there. So I've just gone through and just labelled all those so I know what is what. With things, as I say, it just helps with a bit of diagnosing when things are not working. You come in and look at why is there no power, and just look down and go, well, that's this one, and you see this in the off position. Obviously it's tripped the breaker, but when you just walk up to something, you want to try and get it going as quick as you can and get back going again, if you can fix it yourself, of course. The main thing that's happening at the moment is, as I say, getting all the cables run back from basically from different sensors and so on like that. You can probably see a couple of cables that which you've already seen in the last video. So I've cleaned I've taken all these out, pulled all the cables out of these conduits and given the conduits a good clean. You can see they probably look like brand new, with the same with everything. I haven't done anything. I didn't bother touching the servo motors. I don't want to touch something on them and stuff something up and cause myself a big bill and have to take it to a tech to be able to sort it out because I've touched something I shouldn't have touched. So I haven't touched anything. As far as all I've done is just clean the outside. I haven't done anything else to them other than cleaning them, so they're in their original condition still. As far as going crazy painting everything, transformer you already knew I powder coated, cleaned up these fittings. It's unbelievable. Brass fittings, you probably wouldn't see anything like that on a new machine. Of course you wouldn't be, the age of this machine, it's just what they used back then, but just gone through and cleaned up things like that. So, and you can probably see that big conduit. So this runs all the heavy cables. So this is all the supply cables here. Look at the size of these things. Each one of those cables is one phase. So obviously this is a 3-phase machine, 415 volt in my part of the world. 3-phase. Some of you guys operate only on single phase, but we're lucky enough to have 3-phase in Australia. So as I say, 415 volt 3-phase. If you look at the size of those cables compared to my hand, it's probably rated minimum, I'm guessing, probably at least 100 amps each. It's just crazy the size of the cables they use. Of course, they'd be way overkill, but it was just what they chose to do at the time. Talking of things that sort of blow my mind a little bit is, other than the prices of replacing things, of course, but this big box here, as you can probably see with my hand in there, compare the size of it. This big box here just runs the spindle. Obviously, the spindle needs to run at programmed speeds and so forth, but just the physical size of that box just to run that spindle motor. It's probably a little bit hard to see on there, but because I put the back panel, already put the back panel on, so you can't actually see in the back. Well, I couldn't get in the back anyway, but these guys have seen the spindle motor when I was rebuilding that in some of the earlier videos. Still has the original fan on there. That was pretty clean, and it was fairly quiet. All the fans were fairly quiet, but it's pretty hard to tell when the machine switched on. You've got probably over a dozen fans, cooling fans running at one time, so I'm hoping to sort of drop down some of the emitted noise, I suppose, coming from the machine. It's not the noisy machine, but it's not the quietest machine either when it's switched on, which you'll see when it's running, if it picks up in the video okay. But things that make a lot of noise is airborne noise, so cooling fans do make a lot of noise, especially if they've got a bearing gone in them, but this one I've put back on, so I'll see how it goes. If other fans are quiet, if this one's noisy, I'll be able to hear it, but as I say, there's probably over a dozen fans on this machine alone, so it is a bit hard to find out where one little noise is coming from. But coming back, looking at the spindle drive again, just the physical weight of this thing, I'll be able to just guess, because obviously I didn't weigh it, but it probably weighs, without a lie, it probably would weigh about 40 to 50 kilo. It was just crazy trying to lift it in by myself, even if I had two people, even you couldn't get two pairs of shoulders in here to even lift it in here. They have a little plate that's welded onto the bottom that you can actually sit this on, so you can actually slide the heatsink, because it's got a heatsink on the back of it. I've replaced the two cooling fans on that, because on the back of this is the same thing that's on the door. It has a heatsink that's mounted onto the back of it, so it transfers any of the heat from this into the heatsink, so that sucks air from outside, and then that ducts into the actual where the working end of the cabinet, the working end of the machine, I should say. So there's the fans, so draw air in from the side of the cabinet, which is the end of the machine, up through the heatsink, and then blow that air out into the actual the working ends of the machine. I won't worry about taking you around to show you that, but yeah, it was just unbelievable, just lifting it off the bench. I pulled this apart, more so just give it a good clean inside, took the whole, pretty much, not disassemble it completely, but pulled as much off as I could. Hopefully it works when I flip the switch again, but we'll see how we go when I get to that point. But it was more so just the heatsink I wanted to clean more than anything else. But yeah, the other thing about components on CNCs, which some of you might probably be aware of, but it's sort of a bit like automatic transmissions in cars. Even though they do $100 worth of work, they still have a set price that they do a changeover for, and you can buy these, I think, brand new, but you probably wouldn't want to. But they generally do them as a changeover unit, and I've sort of heard figures being thrown around about $4,000 to $4,500 to do a changeover. So regardless if yours has got $200 worth of problems with it, they still charge you that set fee of $4,000 to $4,500 to swap the unit over. It's the same thing, even if they rebuild yours, they just charge you a set fee. You can, as I say, do a changeover and get going ASAP, or they can rebuild yours for the same price. There's no difference in price if they don't go and they're going to go through it and, as I say, charge that standard fee. So that's one thing you do get stung a bit on CNC machines. Probably the last thing you bring you down on, nothing too big deal, but this is, I suppose, the brain box of it all. You can probably see little serrations on top there, so each one of these has a board. As if it goes with any electrical component, no matter what it is, especially with electronics more so, small circuitry, it just takes one little diode or whatever to fail, and that just kills the board. So these are another expensive things to rebuild or service as they need. But it depends on the tech. Some are better than others. Some will help you out and try to diagnose the problem and just fix one board, whereas others will just charge you, as I say, that set fee. I have no idea what a changeover on these is. I'll probably say it probably something similar to that spindle drive. They just love you when you walk in the door. They even probably make you a cup of coffee because they want to sit you down first and get you settled down before they tell you how much they're going to charge you to do a changeover unit. But it's just one of them things you've got to be aware of, I suppose. When it's just that CNC, I suppose, the CNC machine, no matter what it is, mills, lathes, or whatever it happens to be. It's just the joys of owning a CNC. You definitely pay for them, buying them and keeping them running. But that'll probably do for this video. There's probably not, as I say, not a lot I wanted to show you. It's just a bit of, as I say, a bit of an awakening of some of the things that sort of that I wanted to share with you guys. And just the main thing to do now is just get all the cables pulled in from where they need to be pulled back in from, and The only thing, probably the main thing I got to pull in, the cables I got to pull in yet is probably just the ones for the back of the controller, but they're only little 24 volt cables, so it's just a whole series of these types of cables. To see small size cables, so they're not large, but they are just multiples of them that still need to be connected up into this board here or into this rail here. So different ones running. You see red cables here and these blue cables up onto this board here. But yeah, just wanted to bring in a bit of a look inside there and just show you a little bit of inside the actual machine itself, just for those who are interested. And as I say, just in the mood for another video, just want to do a video for you guys. Well, that'll probably do for this video. I look forward to seeing you guys back on the next one. Okay, bye for now.